Hi folks, welcome back to Physics with Captain Rod. I'm making this video here to help you finish up your lab on trying to measure the free fall acceleration of gravity. So just a quick overview of what you did, right? So remember, you put up this ramp here and you supported it with a bunch of books. I'm just going to kind of sketch those in here. All right, and you measured a height to some point and then a distance along here, which was constant. So that distance that you measure here, or I think they called it length in the lab or whatever, this is constant, did not change. Now, the sine of the angle theta is the height over the length. So when you fill out your data, you should have a bunch of these. These should be very, very small numbers, point somethings or 0.0 somethings, right? So you have those. Then you let this thing accelerate down the ramp, generated a velocity graph, and from using the detector, and you should have an acceleration. Actually, you measured 3 of them, and you should have an average for those. So when you look at your data sheet for the lab, long story short, these are the only 2 columns you have to pay attention to, the sine thetas and the accelerations. Right, for every sine theta, you should have an acceleration that goes with it. So what you're going to do now, I did this over here, you're going to make a graph of the accelerations that you measured against the sine thetas. Now these things right here, depending on how many books you got, these numbers probably didn't get really all that big. They might have gotten to maybe be around 0.2-ish, give or take. Ish is a technical term. Maybe it's a little bigger, maybe a little smaller. Don't worry. But if you have something here like 3 or 4, that's definitely way too big. And if your final number there is like 0.05 or something, that's definitely way too small. But anything right around this for your final one should be just fine. So keep that in mind when you create your graph. Take a piece of graph paper, and whatever your maximum value is over here, run that out to about here. I'm going to use 0.2 as my example. And then when you plot your accelerations against these sine thetas, so you're going to put like this on the horizontal, this on the vertical, you're going to get, a point that might look something like this. Then you do the next one, this on the horizontal, this on the vertical, and it might look something like so. And then you do the next one. You should end up with a graph that might look something like this. Okay, draw what's called the best fit line through it. Take a ruler, and the best fit line, just like its name kind of implies, it's a line that kind of best describes the data as a whole. Maybe something like this. Ideally, it should go through 0, 0. Hopefully it does. If it doesn't, don't panic. It's okay. Now, here's the idea is this, all right? If this became 90 degrees, this car would be free falling. So the idea here is we're going to kind of expand this out. But on our graph here, right, if your theta were actually 90 degrees, the sine of 90 degrees is 1. So that means on your graph, this is way over here somewhere. It's way, way off your graph. That's okay, though. Imagine it being way out here. I'm just going to put an X here to kind of represent that. Now, here's the kicker. This thing is linear. Find the slope. Here's how you do that. Pick any 2 points on the line. They do not have to be data points. If you have 2 data points that lie on that line really well, use them. If not, though, just pick 2 points. I'm going to say like maybe here and here that lie nicely on the line. Calculate your slope by, remember slope is delta, is rise over run. So let me write it like this. I'll call it A2 minus A1 over what should I put over? I don't know what to call that. We'll call it sine theta 2 minus sine theta 1. Well, that's adding needless complication to this, I guess. Find your slope by doing this. That is your rise. That is your run. Get a number. Now, hopefully that number is around 9.8. If it's not, don't panic, but it should be around 9.8. Now, here's the projection part, like how do we use that slope to find the free fall acceleration? Well, the slope of a line, you should be able to use any 2 points. So imagine that we used this one and this one. our rise here would be the acceleration at theta equals 90 degrees. That actually should be our free fall acceleration, g. That's what we're looking for. Divided by, our run, which would be this distance, which would be the sine of 90 degrees. And the sine of 90 degrees is 1. So on our graph, the acceleration that corresponds with theta being 90 degrees, right, if you just multiply by 1, is going to equal the slope of this line. So long story short, when you going back here, once you have this plot and you find the slope of the line between any 2 points, you will be measuring the free fall, or maybe measuring is not the right word, but you will be indirectly, I guess, measuring the free fall acceleration of gravity. You should get about 9.8 meters per second per second. Now, I've had students do this experiment a lot. Here's the thing, it's a very sensitive experiment. It's very, very sensitive to these height measurements in particular. I'm not expecting it to work out perfect. Hopefully, you know, if you got something between, say, 8.5 and maybe 10.5, or I'm sorry, give me a minute here, 10, 9. If you got anything between about 9 and 11, I'd be pretty happy with that result, frankly. If you got something outside of that too, don't worry about it for now. You know, whatever your percent error is, it is, and don't worry about it when you take a look at that. But this is what you should have gotten. Hopefully, it worked out great. You won't be losing any points for incorrect responses, or you know, if it didn't work out perfect. So don't worry about that. So, hope that this video has helped. Will help you get this lab finished. Have a great day.